Okay, welcome to the algebra class. Today we're going to analyze section 10.3, which is the special products of polynomials. In this case, particular, we are going to analyze what happens when we are multiplying certain patterns that are always repeated in the multiplication of polynomials. For example, we have the one that is called sum and difference pattern. For this situation, we analyze that we have a parenthesis that is adding and a parenthesis that is subtracting. The other elements are exactly the same. For example, A and B in this case. After you apply the FOIL method to this multiplication, we end up having this expression. This expression is the one that we call difference of two squares. Why do we call it like that? First of all, difference because it's a subtraction, and two squares because the first element is a square and the second element is a square also. Then the other type of repeated pattern that we may have is the one that we call a square of binomials. For this situation, what we have is a binomial that is adding or a binomial that is subtracting. And what we have in here is each binomial is a square or to the second power. So if we apply the process of FOIL method again, we end up having this repeated element in here, and when we do the FOIL method, we end up having these two expressions that we have in here. The two expressions in here, they receive the name of perfect square trinomial. Why are they called like that? Because the first and the last element are perfect squares, and the ones in the middle are twice the multiplication of A and B. Basically, this is what we are going to deal with, and what we're going to do with the exercises is just apply the formats into solving the problems. So let's analyze that situation. Here I have some suggested problems for you so that you can see how the procedure is going to be applied. For example, exercise number 1. We have 3x minus 1 multiplied by 3x plus 1. As you can see in here, what we have is a situation that involves a sum and difference pattern. One of the parentheses is adding, the other parenthesis is subtracting. So what we do is we identify the elements A and B according to the pattern. A will be 3x and B will be number 1. So we raise to the second power this one, we raise to the second power the other one, and immediately what we do is we simplify the expressions. So therefore what we have in here is 3x raised to the second power. Remember, every time that we work with the second power, we are affecting everything inside the parentheses. Therefore, 3 to the second power becomes 9, x to the second power becomes x squared, and on the other case, on the other parenthesis, what we have is a 1. And in here, we have the final expression, which is what we call difference of two squares. I hope that you see correctly what the pattern is in here. And then I'm going to apply the same process to another exercise. Exercise number 2 is going to be 4x plus 5y multiplied by 4x minus 5y. So if you identify in here, again, we have a sum and difference pattern, and the elements inside the parentheses are exactly the same. What are we going to do in here? Does it affect me that it has two variables? Not at all. You apply only the procedure that we really need to do. In here, we're going to take the first element, which is 4x, raise it to the second power, and then we're going to take the second element, which is 5y, and also raise it to the second power. Okay? Once we do that procedure, then we affect the power to everything inside the parentheses. Therefore, we have 16x squared minus 25y squared. Being this the final answer, because it is irreducible and we cannot combine on like terms. Okay? So what we have in here is the final answer for this expression. Hopefully, I hope that you can see what is happening with the sum and difference pattern. Now, we're going to work the other pattern. The other pattern is the square of binomials. Now, let's remember, the square of binomials means a binomial that is either adding or subtracting and whose power outside the parentheses is going to be a square. So, in here we can have the following situation. Exercise number 3. We're going to have 7x plus 5y to the second power. And in here, if we remember the first thing that we have on the board, written on the board, we are going to apply the perfect square trinomial to this element. In other words, I'm going to do a square plus 2ab plus b squared. This is what I'm going to apply to in this case. Who is going to be a? 7x. Then what we have is 7x to the second power. 2ab is going to be 2 multiplied by 7x, and this multiplied by 5y. And b squared will be 5y to the second power. Once we complete the format, we start simplifying the expression. In here we have 49x squared. Here we can multiply all the coefficients in one multiplication, so 2 times 7, which is 14, and 14 times 5, which is 70xy. And finally, we are going to have 5 to the second power and y to the second power, which will be 25y squared. Then, this is what we call the perfect square trinomial. Now, can this be done with a binomial that is also subtracting? Yes. And we're going to do it in here with the last example for this section. In this case, what we're going to have is exercise number 4. And in here, we're going to have 4x squared minus 9 to the second power. Okay, following the pattern, in this case, the only difference that we have is a subtraction symbol. Therefore, my pattern is going to be a squared minus 2ab plus b squared. This pattern and the one on the top, the only difference is the sign in the middle term, in the linear term. So, let's apply the pattern. The first element, a, is 4x squared minus 2 multiplied by 4x squared times 9 plus 9 to the second power. And when we start simplifying this, let's remember that in here we have a power to another power. And that means that we're going to multiply the powers that we have in here. And this 2 is going to affect the 4. So we're going to have 16x to the 4th minus 72x squared. If you remember, we multiply 2 times 4 and then the answer by 9 plus 81 on the last term. Finally, we end up simplifying this expression like this, and what we have is our perfect square trinomial. Hope that you understood everything in here. Let's wait for an extra video in a few days.